DVC deodorization process. Deodorization is the last process step in the refining of vegetable oils and fats. The process removes the odoriferous, volatile, unwanted impurities from the oils. The operation is done at an elevated temperature of 240 degrees Celsius and at low absolute pressure of 1.5 mm of Hg. Vacuum system V800 is designed to keep the entire process under 1.5 mm of Hg. Live steam is used as a carrier to separate out the impurities from the oil. Let us see how the process works. De-aeration. The tank T801 is kept under the vacuum. It acts as buffer for the incoming bleached oil as well as de-aerator to remove dissolved air. Combined buffer and de-aerator avoids double conveying of the oil during the process. The level in the tank can be monitored by level indication by PLC operation. De-aerated oil is further conveyed by pump P802 to heat recovery equipment REV802 to recover maximum possible heat from the outgoing deodorized oil in continuous way. Heat recovery under vacuum. REV802 is a vacuum heat exchanger where the outgoing product is cooled under vacuum to protect the product and to yield high quality refined oil. The heat energy of 85% is recovered in the vacuum heat regeneration. The feed oil is heated from 100 degrees Celsius to 200 degrees Celsius and the hot oil from 250 degrees Celsius is cooled to 140 degrees Celsius in a continuous manner. The equipment consists of tested U-tube bundles to carry out the heat transfer, and outgoing oil is kept in agitation by live steam. Final heating under vacuum. The heated oil goes to final heater FEV803 to set process temperature. The heat exchanger is a vacuum heat exchanger. Heating of the product is done under vacuum. Heating of the oil at an elevated temperature is done by hot media, either by thermal oil in circulation or high pressure steam of 80 bar. The temperature of the product is controlled by temperature control loop TIC803. The heated oil at high temperature enters in the deodorization equipment D802.1 stripper and retention deodorization column D802. Stripper D802.1 strips off all the volatile impurities from the incoming oil along with live steam entering in true counter current way. Stripper consists of specially designed structured pack where the oil is retained for few seconds. Stripped oil goes to the trays of the column to have desired retention time required for stripping of residual impurities if any and thermal action of the process. Thermal action is a heat bleaching phenomenon and conversion of the undesirable compounds and stripping of the same. The net retention at an elevated temperature has been designed to have low possibility of unwanted reaction during the process. Heat recovery. The deodorized oil is conveyed to polishing operation via heat exchangers E802, HE1 and E805. Heat exchanger shell and tube type E802 is used to cool the oil from 140 degrees Celsius to 110 degrees Celsius and to heat neutral oil going to bleaching process. HE1 is heat exchanger plate type to cool the oil up to 80 degrees Celsius to heat the incoming feedstock to degumming and lye refining process from 40 degrees Celsius to 65 degrees Celsius. Heat exchangers E802 and HE1 makes practically only use of compensating heat during the refining. Polishing. Polishing of the oil is done in the polishing filters PF803 and PF804 in a semi-continuous way to trap any foreign impurities, if any, which can get attributed during the process. Final cooling. The final product is cooled to below 45 degrees Celsius in the final cooler E806 before storage and packing. Vacuum scrubber D804. All the volatiles unwanted impurities goes to the scrubber in bottom and continuously scrubbed with liquid in circulation. The vapors are condensed and are not allowed to escape in the vacuum system. Only non-condensable impurities are escaped and the quantity is negligible. Level in the scrubber is controlled by the level loop and is intermittently emptied. Condensed liquid is kept in continuously by pump P804 via cooler E804. The temperature of the circulating liquid is controlled. Scrubbing has been made advanced to separate out low boiling and high boiling components. High boiling fractions are enriched valuables like tocopherols and tocotrienols. This is done in the two-stage scrubbing with two different scrubbing circuits. The low boiling components is also enriched with a yield up to 95% FFA by physical refining process route.